Hey guys, in today's video we're going to be working with the CR10S Pro V2 and specifically on lightening up the moving parts. We're going to start today with lightening up the bed. As you can see, I got a wham bam on there, and this build surface is fantastic. The only problem that I have with it is that it starts to blister. So you can't see that on the camera, but there's this whole section right here is heavily blistered. So when it does the mesh creation, these appear as high spots in the mesh. And when you print objects on here, they have imperfections. So I'm starting to have to shift my objects over to the right, the front, away from this area, and it's super annoying. One thing that Wham Bam recommends every time you finish a print is to take the build surface off, flex it to remove the parts that you printed. But that for me is annoying to do that every time, and I find myself just pulling the parts off the bed, and that's what causes this blistering and this damage, because it does adhere very well, but you do have to exert a significant amount of force to get the parts off if you're not flexing it off. So we're going to start by removing the magnet. So between the magnet and the stainless steel build surface, this adds a considerable amount of weight. So I'm gonna remove this, and to get this off, we're gonna try using a heat gun and see if maybe we can take it off that way. So let me get you guys in close, and we'll get started. Guys, if you're new to the channel, consider subscribing, turn on your notification bell, and leave me some comments. I love reading the comments, and do my best to get back to you guys as soon as I see them. All right, let's get going. And all I'm gonna do is break out my heat gun, and I'm gonna start working on that adhesive. Now this has a 3M adhesive, so it may or may not want to come off. But we'll give it a shot and see if we can get it going. If we can lift up one of the corners, I know that we should be able to do the whole thing. If we run into problems not being able to get it done with the heat gun, you can always go to using a solvent to break down the glue and then get it off that way. Alright, this is going to be like really hot. Oh yeah, it'll come off, no problem. Okay. Alright, so yeah, it will come off with heat. So yeah, it's almost pulling off right now. Alright, so I'm just going to keep hitting it with heat, and it should release it completely. And I got the heat gun set to the hottest setting. And there you have it. Alright, so it's off. So now I'm just going to go around the edges here with some solvent and clean that up. And then I'll show you what we're going to put in place of the Wham Bam. Okay, so there's little glue bits along the edges. You can actually get off with just your fingernail. So I didn't have to get any chemicals or anything. And I'm just going around the edges and just cleaning that up. You can also use a plastic razor blade. So you can pick these up at Home Depot. They're made out of plastic, but they're shaped like little razor blades. And they're designed to not damage the surfaces that you're scraping. Alright, that looks good right there. A couple little stragglers here of glue. And you want to run your hand on it and feel it and make sure that it's smooth. Alright, so I'm going to show you guys why I wanted to do this in addition to me not wanting to deal with having to lift the stainless steel off the printer every time a print finished. Alright guys, so I got a scale here. I'm going to show you how much this Wham Bam weighs. So there's a couple of things that'll keep you from printing really fast. One thing is processor power, and then the other one is the weight of the moving parts. And then lastly would be your hot ends flow rate. Alright, so I'm gonna put this roll of tape on here. I'm gonna zero this thing out. Alright, so you can see the Wham Bam with the magnetic sheet is 757 grams. So what we're going to be using is our G10 Garolite. Let's see, I can do this. Move this back here. Alright guys, so there's the Garolite. As you can see, it comes in at less than half the weight of the Wham Bam. So this is going to reduce our moving mass on the y-axis and allow us to print faster once we get Clipper installed on this thing. Alright, so this one is the prototype. We're going to have it available on Amazon soon. As soon as it's available, I'll make another video. That way you guys that have been asking about the custom cut G10, similar to the one that we offer for the Ender 3 V2, Ender 3 Pro, Ender 3, and VoxLab. Now you'll have one for the CR10S Pro V2. This will also work on other printers that have a 310 millimeter by 320 millimeter print surface. So you guys can utilize the same one. All right, let's get it installed and we'll do some testing. Now we made sure that this Garolite was designed and precision cut to fit specifically the CR10S Pro V2. So when it's mounted on here, you'll see all the radiuses match up perfectly, and it looks dynamite on the printer. All you need to install this is some small binder clips, and these that I'm using are they're 0.5 millimeter wide, and I'll put links to all this stuff in the video description. That way, if you guys are interested, you can. And they're 5/32 inch. These things are really small, so they're not going to get in the way. And I like putting them just on the inside. And now there's no Garolite that's going to be perfectly flat. So I don't recommend you guys using this unless you're running some type of firmware that allows for universal bed leveling, or some other way that you guys can create a mesh. Clipper is excellent with these build surfaces. I run them on my Ender 3 V2s, Ender 3 Pros, and it works great. Alright guys, so we're running Miguel's professional firmware, and this one was compiled specifically to work with the CR10S Pro V2 build volume. So let's home it. Alright, first before I do anything, I'm going to do the bed trimming just to check my corners. Alright, Okay, let's create our bed mesh. So you go to the prepare, which is the second one from the top. Click on that one and then go down to where it says auto build mesh. And then it's going to home the printer, warm up the bed, and then create the bed mesh. All right, once your mesh is done, go ahead and save it. And then I'm gonna print a test part, just a single square in the middle, just to check my Z offset. Perfect. So this is exactly what you want right here. So you can see the gap. It's barely holding on. And then look at what the top looks like. See, there's no stringing, there's no clumping or anything. So look at that compared to the first one that we printed. So here was the first square. You can see all the clumps and the stringing and problems. And then look at the bottom. It's all smooth. You don't see any definition or anything. So a properly set Z offset will look like this. Perfect. So now if you need to remove a brim or something, the brim will do its job because it's barely holding on to keep the part down, and then to remove the brim is really easy. All right, so I'm going to play around with the bed mesh, and then I'll fire off a test print. I'm going to jump on Onshape and create something that we can print that's big, so that we can check the UBL on different parts of the bed. I'm going to do my best to not mess this thing up when I try to take it off. And what I did is I made it two layers thick to make it a little bit more robust. My original one was only one layer, and I was breaking it as I was trying to take it off the build plate. Yeah, G10 is amazing. You just have to be careful with small stuff because it sticks so well that you gotta be gentle lifting it off. And this is with the bed totally cooled. If the bed was hot, these things would not come off. I mean, you would be destroying them. Try to get this one off. Hopefully, I won't break it. There it goes. All right, got it. All right, let's move it over here to the bench and we'll look at it. All right, let's turn on the light. All right, so how I use this is I have one side. I think it's this one here. Okay, so this one is the beginning one. So this is the 0, 0 position, which will be left front. And then what I do is I turn it over, and I just look at the bags. You can actually put it like this. You can put it flat with the reference side facing you the way it would be on the build plate, and you could just lift this up and look underneath each row. So this one would be 0 0. This one would be X 0. I'm sorry, 1 0, 2 0, 3 0, 4 0, 5 0, 6 0, 7 0. And then the following one would be 7 1, and then it would be 6 1, 5 1, 4 1, 3 1, 2 1, 1 1, and then 1 0. So that's how it coincides with the mesh in the machine. So when you're going to edit a point, you need to keep that in mind. So it starts off. So this is 0. So this is on the Y. Okay, 0, 1, 2, 3, 4, 5, 6, 7. On the X, it's 0, 1, 2, 3, 4, 5, 6, 7. And then all the other points in between are just different combinations depending on which row you're at. So for example, this one here would be 7 0. This one would be 7 1, 7 2, 7 3, 7 4, 7 5, 7 6, 7 7. And then the next one would be 6 0, 6 1, 6 2, 6 3, 6 4, 6 5, 6 6, 6 7, and so forth. So anyway, that's how you read this. And then what I like to do is I like to look at the bottoms. Right, so if you could see, let me see if I can zoom in. Maybe you guys can see a little better here. Let's see. Yeah, you can see that. So this is good. First layer squish. Actually, it might be a tad too much, but I mean, for all purposes, it's good. It could probably be a tad higher. And what you're looking for is you're looking for troubled spots. All these actually look pretty good. I don't see these over here like this one. If you look at this one carefully compared to, see if I can get the light just right. You look at this one compared to this one. You can see that this one is probably a bit too high. So this can come down. So this last row seems like it can come down a little bit. It starts to get better over here. But yeah, these first ones here need to come down. So if I wanted to know, sorry, got you guys off frame here. So if I want to know what these numbers are, all I do is I just flip this thing over this way. And this one would be over here on this side, would be 7 7. I'm sorry, 7 7. And then it would be 6 7, 5 7, 4 7, 3 7, 2 7, 1 7, 0 7. So that's how you would find it here. So let me edit. Let me go ahead and edit these points with you guys watching. See if I can do this without causing too much glare on the screen. All right, so I'm going to go to my menu. I'm going to go to Advanced. Click on Mesh Leveling. And then I'm going to go down to Edit Mesh. And I'm going to type in the mesh coordinates. So we said it's 7 on the X. So we're going to put that to 7. And then Y is also going to be 7 because it's all the way on the back part of the build plate. Change that to 7. And that value right now is 33. So we want to make this a little bit lower. So if we look at it again, yeah, it's a tad high. So we're going to bring it down a little bit. And I'll bring it down to like 0.30. And save it. And then I'm going to go to the next point. Next point is going to be over 1. So it's going to be X. So when you're moving from right to left, you're going to go down on the X value. We're staying still on that same row on the Y. So we're not going to mess with that. Next point is 22. We'll make this one like 19. And then we'll do the same with the one next to it. So X5. And we'll reduce this by 3. That would make it, what? 1, 10, 9, 8. Yeah? Yeah, 8. So this would be 8. Save that one. And then we'll do the same with the one next to it. So it would be X4. This one's already at 0.08, so we're going to change this one to 0.05. And let's go over to the next one. This one will be 3. This one's 14. We'll make it 11. And then the ones that follow look pretty good. Yeah, the ones that follow look good. All right, and then that's how you do it. That's all there is to it. To fine tuning the mesh, you just have to, once you create the mesh, print something. I'll make this file available in the video description if you guys want to use it. Now this is specifically for the CR10S Pro V2, running an 8x8 grid using Miguel's professional firmware. But if you guys are using like a Ender 3 V2 running the same firmware, you could use this grid. So long as you're running an 8x8, you would just have to shrink it down, scale it down in Cura so that it will fit your build plate. One thing you want to make sure that you do after you change your values on your mesh is to go back and save it. So I'm going back to mesh leveling right here up at the top, save bed mesh. I'm going to click on that. It's going to beep. Mesh 0 saved, and that's it. So now the next time you restart the printer, those values will be saved there. It's kind of a good idea to keep some notes. That's something that my good friend Doug O'Connor is always telling me to do. I'm real bad about that, but if you keep notes on what the value was before you changed it and what the new value is, well, the new value, you'll know what it is because you can look at the mesh. But so like, let's say you brought it down too low, but you forgot what the previous thing was. It would be a good idea to have those notes. That way you can better determine the proper height. All right, guys, if you're new to the channel, consider subscribing. Turn on your notification bell. If you like this video, give it a thumbs up, and I'll see you guys in the next one. Take care.